Thanks for the introduction, Matt. So like you said, my name's Shane Whitaker, work in manufacturing technology. So I'm from Lockheed Martin, so specifically Lockheed Martin Aeronautics. I'm based out of Fort Worth, so that's where we make the F-35. So that's our plant over there. We have a few other areas that I'll talk about here in a bit. But kind of the role of our group, like I said, it's manufacturing technology. We're all applications engineers. So kind of our job is to work with the production floor and identify problems and challenges in the production area and see if we can address those with technology and industry and work with integrators to integrate solutions to that. So aerospace engineering has its challenges. So, our team is quite big. We have about, 70 people across 3 different sites. So we do fabrication, metrology, and of course, robotics and automation is a big one that we're focusing on. So yeah, in addition to that, we kind of do research and development internally, and then we also work with integrators to kind of integrate those solutions. So we do a little bit of both, but a lot of our, kind of job role is making sure these systems get integrated into production and kind of supporting them as they go on. And so, yeah, we recently joined the ROS-I consortium. So I've worked with SWIRI in the past, so got my exposure to ROS Industrial through there, and yeah, we recently became a member around March, I believe. So we're trying to focus on what we say agile automation going forward, and so we think yeah, ROS-I is going to help us with that. So I'll kind of go over that today. All right, so just quick agenda. So I'm going to give an overview of Lockheed Martin, just kind of get everyone an idea of the products and kind of volumes, challenges that we face, and go over the different business areas, things like that.
Oh, you hit share screen.
Rookie mistake.
Details. Sorry for the interruption.
Yeah, no worries. It's my fault.
Yay. You can hit the 3 dots, and there's an option to hide that or hide and looking.
Perfect.
You can minimize the camera. Sorry, everybody.
It's all good. Get that out of the way. All right. Yeah, anyway, so give an overview of Lockheed Martin. We have a bunch of different products. I just want to give an overview of that. And then kind of some of the challenges we face and kind of the need for why we're trying to go towards this agile automation going forward. And then, obviously touch on how we think, ROS enables that and why we ended up joining the consortium. So, all right. So Lockheed Martin, broken up into 4 different main business areas. Decent sized company. I have over 100,000 employees worldwide. So like I said, I am from aeronautics, and then we also have our missiles and fire control, rotary and mission systems, and our space systems division. So like I said, I work at aeronautics. I'm in Fort Worth, Texas. So that's where we work on the F-35. That's kind of the top left picture. This is more of a replacement for kind of F-16, and a lot of those is our 5th gen fighter. So this is one of our larger programs. We have a few thousand on order. So yeah, so that's one of our main products, but we also have a couple other divisions. So we have our Palmdale location. So that's going to be our Skunk Works. They work on, kind of next generation aircraft. So SR-71 being one of those in the 60s. So it's kind of one of the ones they're more famous for. And then in addition to that, there's also our Marietta plant in Georgia. So they work on cargo airplanes, the C-130, C-5, things like that. So a bunch of different types of products, as you can tell just from that. And then so that's just one business area, missiles and fire control. As the name alludes to, they do just that, missiles, and then they also do other technologies, kind of support the soldiers on the line. And then we have our rotary and mission system. So as the name implies, I like to make it obvious. We do helicopters. Actually acquired Sikorsky a few years back, so they're under our umbrella. And then mission systems is also supports a number of things, naval operations, things like that. And then, yeah, last but not least, my favorite is space. So do a lot of work with NASA, the Artemis program. We built the Orion capsule, so that's one of our main products there. And then the InSight lander that went up a few years ago. So yeah, kind of exciting on that front. And then I know actually a few of the folks on our space team have been involved in some of the space ROS things that Dave Coleman mentioned earlier. So obviously another, initiative of why we would want to be in ROS industrials. Right. So kind of want to define the need. So, and I'll just define what we mean by agile automation, because different people may have different definitions, but for us, it's the ability to rapidly and efficiently develop and deploy robotic systems to meet evolving requirements. So why is that important to us? So our product volumes are relatively low compared to automotive or anything like that, where they're pumping out hundreds of thousands a year. F-35 is our big program, and we maybe put out on the order of 130 to 140 a year. And then even our missiles and fire controls, they get orders annually, so it can kind of switch. You may be making 100 of this year, 400 next year. Kind of just depends on the need. So our factories need to be able to adjust for that. And one of the other challenges, products generally aren't going to be designed for automation. Given some of the complexity of the systems, big part of the design is really just getting the mission capabilities and operational capabilities working, and then manufacturability can kind of be an afterthought. Hopefully that's changing going forward, but that's certainly a challenge we face. A lot of the things are still made to be done by hand. That's kind of how they did in F-16 days. So the same kind of mentality is still there, but I think that's going to change a little bit going forward. And yeah, so like I mentioned, F-35 is our big thing, but going forward, we get the impression that everything's going to be, particularly for aeronautics, and be more the high mix, low volume environment. So need to be able to, repurpose and reuse robots to kind of justify that return on investment, because, we may not have, thousands of aircraft to justify this return on investment. So, if we can have robots that, can be working on, this aircraft, and then, once it's done, go to a next one. That would kind of be ideal for our business model going forward. And so that's kind of why we have here the program based, which for F-35 has been good. There's a lot of places where fixed work cells make sense, but one thing that we notice across the different programs is we do a lot of the same tasks, just for different geometries and things like that. So we are trying to go more from program based point solutions to kind of task based solutions that we can redeploy in different areas. All right. And then, on top of that, so aerospace just has, general unique challenges that you may not see in a lot of other areas. So a lot of tight tolerances. So we have to do a ton of metrology, measurement, and inspection, to make sure we're actually meeting those tolerances. So that's a big thing that's, in our processes, and a lot of what our group works on trying to solve those things. And then you get a lot of complex geometry as well, large surface area. And you're trying to make path plans for pretty complex geometry. You got to put the robots in like inlets and things like that, which can generally be pretty challenging. And then registering the smooth surfaces maybe a little bit harder than kind of more box shape or something like that. But anyway, so as the product changes, like I said, high mix, low volume in the future. One of the things we're kind of looking to do going forward is really shift towards some of the mobile platforms versus kind of having a lot of fixed work cells and tooling. So traditionally, in some of our legacy programs, we have a ton of aircraft going out, so we make tooling, and that's how you end up tying certain machines into the coordinate system. And it works well where it makes sense. Going forward, if you're making 10 of something, you kind of want to reduce that tooling impact and have a mobile system where you're able to come up to the part, have the robot work on it, versus having a cell where the actual part flows in, because that could change depending on requirements and what we have coming down the line. So big thing for us is now that puts the need on collaborative applications and working in unstructured environments, which a few people have already touched on here, but that's a big enabler for us, because that's something we see, going forward that we're really going to need. And so, and then in addition to manufacturing, I'll also touch on sustainment. So we do have, like I said, several aircraft going out. So sustainment's also a key part of that role. And so, aircraft eventually need to, be scuffed and refreshed for coatings, laser ablation to remove, and then actually apply the coding back on, and different operations out there. And you can imagine the bases aren't going to have just one type of aircraft; they may have several. So, and the infrastructure to actually accommodate the multiple aircrafts would be pretty difficult. So, and pretty costly and they don't always have a ton of budget. So the more you can reuse and kind of have a flexible, agile environment, that's more ideal for kind of those types of applications. All right, and so one common, or one observation, I guess, I can make from some of those challenges that I was mentioning. So a lot of that in working in structured environments, kind of repurposing robots, a lot of the challenges in the software side of things, hardware. I'm sure there's going to be ineffective development and various things to actually get it working for our specific processes, but a lot of it is actually getting the software to adjust to new geometry, or be able to go work on a new part. So that's where when ROS comes up, the advanced perception and motion planning is something that we see as being able to take the most advantage of and use it in our processes. And then and for us, we're, like I said, a decent sized company, so we have a number of different robots. It's not like we standardize on just FANUC or one, but we have several across the facility. So robot agnostic capabilities are a big thing for us. So we develop something on one robot, we want to be able to go use it on something else. But that was also another big thing about ROS when I first started learning about it from the SWRI folks, is this can be applied to multiple different platforms. And I think that's going to be important for us because we can do a lot of development on collaborative applications, but we need something like a larger reach industrial robot. We can take all that knowledge and actually transfer it. And then pretty cliche, but reinventing the wheel. So yeah, in our group, I've seen this plenty of times, and it's kind of funny. There's a lot easier way to do it in ROS. I've kind of pointed towards that before to some of my former colleagues, but they ended up going down that road anyway. So that's another reason I wanted to get in this. Be able to get some training, be able to utilize those capabilities, and make sure we're not spending time reinventing the wheel and really focusing on the application. And then like I said, so my group works on a lot of pilot systems, and so any code reuse would be great across sites. And so not just aeronautics, but across all of our BA space, RMS and all those as well. And then one other thing I'll touch on, so we are also part of the ARM Institute, and we've been part for a few years. So obviously everything in there is done in ROS, so that's been another kind of key point. You're developing new applications, new capabilities, and they're all done in ROS. So we want to leverage some of those going forward. It kind of makes sense to follow that lead and kind of embrace it a little bit more. And I'll get into this. And then so like I said, we're applications engineers, and some people have already touched on this today, but we're not software developers per se on my team. We have a few people that can focus on that. So it's been nice actually to see. I think when I came back in 2019, came to this meeting before, and a lot of the feedback was, hey, we need a lower barrier to entry to actually use ROS. And it's been cool to see the community actually take that feedback and start building applications for people like on our level who are spending a lot of time on the production floor, may not be able to sit down and write a bunch of code, but you can still leverage the capabilities. So I'm sure we'll hear more about this. I think SWORD's the correct acronym for one of these. And then obviously the behavior tree and interactive tools. So this was the post-day one, but also Move It Studio is a great example of how we can get to that higher level of abstraction for a few of our folks to go and integrate in different areas. And then also, just on that note, Windows support is kind of a weird thing for us. I still prefer Ubuntu, but a lot of people in my group, we're kind of a Windows company. You don't really get an Ubuntu machine too easily. So it is nice to hear that, Windows support is taken seriously, and, cross-platform support, especially a lot of the guys in our group, that's kind of what they focus on. And so, already taking on something new, like with ROS is, maybe intimidating. So at least staying in their own operating system maybe helps them do that. And then, of course, DDS, nature of our work. So security and reliability is important. So our customers, always happy to see, that being incorporated. So. All right. And then kind of one of the other things, so for us, as you're developing these autonomous capabilities and kind of scan and plan applications, it's kind of a good idea to give the robot operator an idea what the robot's going to do. So, this is one example of something we've seen, where it's a scan and plan application. This actually kind of directly ties into sustainment. But, you give the robot an idea where the actual part is, and then it goes and scans it, and it can actually plan it for kind of spray applications. And so, this is, like I said, important. You want to be able to give the user the visual feedback to make sure, before you go run an industrial robot in kind of a more unstructured environment, they have confidence of where it's actually going to go and, not crash into anything too expensive. Yeah. And then, in addition to that, so we did deploy our first ROS-I system in 2020. So we had a pilot back then. So this one actually kind of fits what I've been alluding to a little bit on the Agile automation thing. So this is a more mobile system that was doing an inspection on the F-35. Kind of not necessarily a scan and plan, but kind of register to the part and then inspect the surface and then give visual feedback to the operator. So this is something I worked directly with the Swery folks on, kind of my, I guess, first main exposure to ROS. I was aware of it before, but didn't really, know too much about the capabilities and what it could do. So this was real eye-opening for me. And then, since then, been kind of an advocate, at least in Lockheed, that we should start using this kind of going forward, because this is one of our first systems that fits the model of being able to, redeploy if you need or go do another job. And then, on the mobile side, it's on the mirror, which also runs ROS on the hood. So it's kind of in our interest to make sure that's, that's industry ready and, improved upon. So we're certainly interested in that. And then also, so kind of what you saw on the last one, we support the ARM Institute, and there's a project focused on sustainment. So this is kind of, there's a video playing earlier. But this is a perfect example of, sustainment application, where the scan and plan that kind of alluded to. As you can see, it's on a mobile base, got the little ROS sticker there. So this was an important one to get, a few folks on board with, this is going to be important going forward, especially as, we move to the high mix, low volume environment, being able to drive up to the part and, spray as needed. And then also some interesting work from Swery is kind of the coordinated mobile base and arm. So, you get some of that stuff working. That could be, pretty useful for our use case. So, of that. So, and kind of wrap it all up. So, summary. So, aerospace manufacturing, we certainly have several challenges that need to leverage the flexibility and capability of ROS. And, we've noticed that there's been a ton of tools that help us actually achieve this going forward and make robots more adaptable to autonomous solutions rather than, kind of your fixed automation. So, even though we are early on in the adoption of ROS-II, we definitely see, or ROS in general, we see it as a key role going forward in kind of developing our Agile automation strategy and support, our factory of the future and be able to adapt and redeploy. So, with that, that's all I got. So, questions?
Yeah, we got some time for questions for Shane. There's something about Lockheed and they're trying to do. Obviously, a little aerobotics shot out there, right? So they were a contributor on the mobile project.
All right.
All right, looks like you're off the hook, Shane. Oh, wait, gosh, thank you for your time. I saw your robot on that. Are you using the ROS version of that, or are you covering robotics yourself and then ROS, like peripheral, like vision and all the other stuff?
Sure, Matt may be a little bit more inclined to answer this one.
The trajectories, Spannick. Did we do a post processor?
Yeah, I think on that project we were using the Spannick ROS-I driver, but we were using it just to joint states back from the robot and we were remote planning right and native programs. So we did like your hybrid.
So yeah, I mean, the one interesting thing about these approaches and the different types of drivers is that flexibility. I mean, right. So in this particular case, because of the nature of the Panic robot and what we had to do, right? You mentioned obviously interacting with the IO. There is now an update even to that old Panic driver. You can actually interact with the IO on the fly right through the ROS. At that time, that wasn't there, right? So the nice benefit of actually translating all of the ROS trajectories into native Panic code is we can actually then access the IO. And so that's sort of, we call it hybrid, but it is sort of a lowest area to entry. You get pretty consistent motion. Actually, the send the Panic what it wants. Right. We have a similar approach we do with all the other types actually. But sometimes that's a nice option. It's fairly robust if you're not trying to do stuff that's super dynamic while processing. Excellent. Yes, Adam. Oh, he might have unplugged.
Yeah, sorry about that.
Was there another question? Oh, sorry.
Basically, your sort of example, you're using ROS, for example, for second like one for inspection or but you know, ROS2 is based on TBS and we need to get a lot of full complicated framework of military. Are you basically using some sort of results and relate it to the main target, the main things that you're doing, or just
Yes, certainly more utility. I think the question was like, are we using that a lot in our products or just kind of, manufacturing based? So not in our products just yet. I mean, I know there's some people who at least do development in it, but yeah, mostly as a utility. As you mentioned.
But it's so similar you're doing, then you're basically contributing that across other things.
That's probably we don't see a lot of crossover. You mentioned ROS-M specifically. Yeah. So today, currently not a lot of crossover. I mean, right, just because of the nature of the programs and where they're both kind of heading. But yeah, there should be a convergence at some point, a little bit more convergence and crossover. So fortunately, we have folks within our organization that are actively involved with ROS-M, right? So that's definitely been something on the radar. But currently, there's not like a ton of crossover. So yes, there are some things. Yes, one more, I guess. Landon.
And I would say, I was wondering, this application was looking at inspection and delivery material processing. Where do you see like Lockheed going in the future applications for ROS? Do you see more utilizing for inspection or the material processing application?
Yeah, I think it's going to be a lot on the inspection side. Or one of the things we do a lot of surface planning, so you can imagine like the spray application, inspection across the surface, sanding. So we do a lot of type of things like that. Do a ton of hole inspection and things along those lines. So I think that kind of those are the main problems that come to mind. I'm sure there'll be more going forward as new manufacturing challenges arise, but those are kind of a few off the top of my head.
It's typically we see it a great place to start, right? You could obviously, for those of you who are Harness members, go into the member portal, type in Lockheed Martin, and there'll be a couple there. A lot of standing, a lot of surface kind of processing, but also a little bit forward looking, like with textile, right? The composite layout that you guys do. So there are sometimes things that are a little bit more forward looking, but in the end, it's surfaces, surface processing, and then I guess in composites we fit this creation.
Yeah, fabrications.
Right. So, but yeah, I mean, it's been some really interesting things, but there's a lot of that low hanging fruit. Inspection is great. Well, thank you, Shane.
Yeah, thank you.
For sharing your experience today.